Hi, welcome to question 7, 2016, paper 2. This is the first question in section B, and you can see here it's worth 55 marks. Just to this question, it's not too bad, so we'll get stuck in. Now, I suppose before we tackle every section, I'm assuming that you've paused the video and given it your best shot, so you're familiar with the question and have read it a number of times. The Atomium in Brussels is one of Belgium's most famous landmarks. Who cares? It consists of 9 identical spheres joined by 2 types of cylindrical pipes. So 9 spheres, okay, you're right there, 9 spheres, let's put it like a circle or whatever, and 2 cylindrical pipes, okay. So let's just get my brain stuck around it. Okay. So the atomium is modelled on an iron atom that has been magnified 165 billion times. Given that a billion is 1,000 million, write 165 billion in the form a by 10 to the power of n, where n is an element of z, so that means n is an integer. It'll be a positive or negative whole number, it won't be fraction, it won't be 0. And a must be between 1 and 10, but can include 1, but won't include 10, so basically between 1 and 9 inclusive. Pretty standard scientific notation question. I'd say why not visualize what 165 billion is before we do anything, okay, to at least get you the attempt. So 165 billion, so it's 1,000 million, so 1,000 is 3 zeros, a million is 6 zeros. Okay, so that's 165 billion atoms. Now, you want to express this where your first numbers are between 1 and 10. So your decimal point starts off at the end. It's going to move the same times as the number of zeros. So 1, 2, 3. So that's 3 times. Another 3. And another 3. Now if you put your decimal point here, that's 165 by 10 to the power of 9. But they specifically state that your first number must be between 1 and 10. So you have to go 2 more times. Okay. And your decimal point will end up where the cursor is now. Okay, so that you can write that as 1.65. Okay. By, now how many zeros, how many numbers did we jump? 3 and 3 and 3 is 9, and 2 is 11. So 1.65 by 10 to the power of 11. Now, one thing you could have done here was put your 165 billion into the calculator, press equal, it will straight away go to scientific notation, saving you all that work. So don't be afraid to use the calculator and test it if you can. And that's part A. Okay, so the answer is built in there. Part B now, assuming okay, if you haven't already attempted the entire question, pause and give it a go. Now, part 1 here is ridiculously easy. So the diameter of each sphere in the atomium is 18 meters. So first I'm writing down here is diameter equals 18. And the first part there, find the radius of each sphere. Now we should know the radius is half the diameter. Okay, so the radius is equal to, now if you want to go long-winded, say 18 divided by 2, which is equal to 9. And very important here is put in the units, 9 meters. So that's part 1. Now part 2 here, find the volume of each sphere. Now I would say when tackling this kind of area volume question, you're in your element if you know that the formulae are all in the maths table. So I would look at the question and go, well, if they want volume, it's a sphere. And then I'd open up my maths tables. Now I have them open somewhere. Okay, I'll close them down. I have to go looking for it. Bear with me for a second. I have a digital version of this, which I'll be including in, I can include which for you if you want. So area volume, so I click it, it'll bring you straight to the formula. There's the area, surface area for a cylinder, volume of a cylinder, surface area of a cone, volume of a cone, and most importantly for us, you have surface area of a sphere and volume of a sphere. Be careful to take it down properly from the maths tables. The volume is equal to 4 over 3 times pi times r to the power of 3. Let's go back to the notes here. I have the answer built in, so don't mind me writing it out. It's right here. So I have the formula, got them from the math tables. Now, in this formula currently, there's technically three things you don't know: the volume, pi, and r. Now, pi is a known constant. You find it on the calculator. It roughly approximates to 3.14. The volume is what you're looking for, so you have to kind of copy that you have the radius which you found in part 1. As we've said before in different videos, let's just say for some reason you couldn't find the radius, but you knew you needed it for the formula. Make up an answer, nice round easy number, and go with it. It'll be accepted as correct in part 2. So anyway, I'm putting in the information I have. Now, I'm not putting in pi here just to save me having to type it, but I'll use the pi button on the calculator when I'm putting the formula into the calculator. So fraction 4/3, brackets pi, close brackets, open brackets 9, close brackets to the power of 3. So if you put it in properly, it should go straight to this answer. Now they want your answer to 2 decimal places, so you have to press the change button, and it will convert the 972 times pi into its decimal equivalent. That'll be a long decimal, and you just round it back to 2 decimal places. And again, make sure to put the units in. Okay, so that's B part 2. Pretty straightforward. Move on now to C. So again, I'm assuming you've paused this and had a go at it. So find the combined surface area. Okay, so it's important here now is not volume, it's surface area of all 9 spheres. So it's only the spheres they're talking about. And correct means rounded to the nearest meter squared. Now the formula built in here, I've taken it from the maths tables, but again I can flick back to the maths tables. You'll find surface area of a sphere, the formula just here on top. Okay. Now I know that the radius of those spheres, okay, is 9. Okay. I know that pi is pi, so it's pi button. So I can just throw them directly into the formula. There's nothing strange going on here. So I'm doing it here, got the formula written out. Okay, now actually I've done here just to make things different than what I just said. I'm already multiplying by 9 because they asked for the total of 9 spheres. So it's 9 times 4 pi r squared. If I put my 9 in for the actual radius, now it's just by pure chance that there's 9 and the radius is 9. I can put that directly into my calculator and I'll come up with the answer 2916 times pi. But they wanted not in pi form, or in terms of pi is what they normally say it. They want it given in decimal form. So I press the change button on the calculator and displays my decimal 9160.88. And they did say in the question they wanted rounded to the nearest meter squared. So 9161 is closer to that than 9160. Job done. Okay, so I'll move on to part D. Now let's get a little bit more complicated here, and the questions generally will more specific. So be very, very careful reading them that you know what you're actually answering. It'll often involve rearranging a formula to find an unknown that's not like straightforward, so just be aware of that as well. So first thing, each of the 8 cylindrical pipes extending from the center sphere has a radius of 1.65 meters and a length of 23 meters. So I would suggest, look, I mean, very roughly on the side, I'm just going to draw a cylinder. Okay. Now, the cylinder has a radius of 1.65. Okay. I'm just going to put that equals R. In one sense, you're kind of going, why bother doing this? But one very good reason is you'll get the attempt because you've done one correct relevant step. That's supposed to be meters, okay? So saying find the sum of the curved surface area of all 8 pipes, okay, and then round to the nearest meter squared. So actually kind of like the last question, okay, just to go get the right formula. Now the curved surface area of a cylinder, I'll go back to the maths tables, you'll see it here, okay, it's the curved surface area. Now it's not given in, they say they use the letter A in the maths tables, but if you look up here in what describing what A means, A represents the curved surface area. So they are telling you, but it's telling you in a supposed roundabout way. I'd argue they should be a bit more clear. If I go back here, I have formula written on the notes. I'll go straight to the answer. So curved surface area equals 2 pi rh. You know pi, it's in the calculator. You know r, okay, in this case it's 1.65. They just told you down the question. And you know h is 23. So you have all the unknowns in the formula. You're just looking for the curved surface area. So plug it through the calculator. Mine comes out in terms of pi. Press the change button. And in the same job, I'm multiplying that by 8 because there's 8 pipes. Now, I marked this paper back in last year. Very common mistake was to forget to multiply by the 8. Just be aware that. Make sure you read the question. As I said before, going back over the paper at the end when you, at any spare time you have, and reading over the questions again will often catch that kind of error. So D part 2, the other 12 cylindrical pipes connect the outer spheres to each other. Each pipe has a radius of 1.45 meters. All 12 pipes are equal in length. The sum of the curved surface areas of the 12 pipes is 3170 meters squared. Find the length of one pipe. Now I need a break because I'm knackered after reading that. There's an awful lot going on here. Okay, so just got to break it down, each sentence by sentence. So there's 12 cylindrical pipes. Now I often suggest, look, I'm underlining it here, but if you have a highlighter, highlight the bits that are important. Okay, pipes connect the outer spheres to each other. Each pipe has a radius of 1.45 meters, so that's going to be important. All 12 pipes, so you know the 12, are equal in length. Okay. The sum of the curved surface areas of the 12 pipes is 3170. Find the length of one pipe. So if the curved surface area of all 12 pipes is 3170, what's the curved surface area of one pipe? Well, you're going to divide the 3170 by 12. I end up with a figure of 264.17 here. Now that 264.17 is the area of one pipe, so you can put that equal to the curved surface area formula. So it's 264.17 by 2, my battery's almost dead, by 2 pi RH. So I know the radius is 1.45. The only thing left here I don't know, normally I would know the curved surface area, and I'd be looking for the height, or sorry, looking for using the height and the radius to find the curved surface area, but here I know the curved surface area. So the unknown here is h. So I can rearrange it if I want. But ultimately what I'm doing is I'm bringing the 2 pi times radius across the equal. Now they were multiplied on the right. When they come across, they'll be divided. So the 29 meters I got there is the result of dividing the 264.17 by 2 pi times 1.45. Job done. Okay, we'll move on. Now we're on to 7D part 3. Okay, so the curved surface area of the 20 pipes and the 9 spheres are covered in stainless steel. Stainless steel costs €70 per square meter. Use the areas you calculated or have been given above to find the approximate cost of the stainless steel. So go back over your answers and look at, do you have the 12 pipes, then the 8 pipes and the 9 spheres? You'll have the curved surface areas of all that, and just go ahead, add them together. So go straight to the answer here. I've taken them from part 1, part C, and part 2. Okay, so 1908 plus 9161 plus 3170. So have a think about that, what we're doing. Okay, even again a drawn might help. But the total area is 14239 meters squared. Now the statement there, they give you a conversion factor. If 1 meter squared costs 70, what does 14239 meters squared cost? Now it's obviously going to be a lot of money, but it's the same principle. You're just using the equation, you're multiplying up both sides by the amount you're looking for. And for example, a simple example, if I said, what does 2 meters squared costs? Well, I'd multiply both sides by 2, and it would be €140. 3, 4, 5, any number you want to multiply up by, you're correct as long as you multiply both sides by that number. I had to put a figure of what's 996,730, so it's almost a million. Okay, 996,730. Job done. Now that's question 8. So again, have a look back at that, either again now or in the next few days to try reinforce it. But the biggest thing I can say to you here, you get into the question 7, 8, 9s, that they're almost impossible to help somebody do them, because ultimately on the exam day you're on your own, and you have to make the connection on your own. So practicing these things, if you get stuck, fair enough, go look for a clue. That's what learning is. But without doing that hard slog, you'll be sitting the exam on a lonely day in June, suffering the same problem as now. So practice makes perfect. Okay, so thanks a million.